How do elastic and plastic deformation apply in real life? Imagine bending a paperclip or stretching a rubber band. These everyday actions show how materials respond to forces, and understanding this helps us see why things break or last. When you pull on a rubber band gently, it stretches but goes back to its original shape once you let go. That's elastic deformation. It's like a spring that temporarily changes shape but recovers fully. This behavior is important in things like shock absorbers in cars, where the material absorbs energy without permanent damage. Elastic deformation happens when the stress, or force per area, stays below a certain point called the elastic limit. If you stretch a guitar string, it vibrates and produces sound because it stretches elastically. The string returns to its original length after you stop pulling, thanks to elastic behavior. Now, if you pull harder on that guitar string or bend a metal wire too much, you might see a different response. The material might bend or stretch permanently. This is plastic deformation. It's like bending a paperclip so it stays bent, or denting a car's body panel. Plastic deformation occurs when the applied force exceeds the elastic limit, causing atoms inside the material to shift permanently. This change in shape doesn't go back even if you remove the force. For example, molding clay into a new shape involves plastic deformation. It's a key process in manufacturing, like shaping metal into parts or forming steel into rebar for construction. Understanding the difference between elastic and plastic deformation helps explain why some products last longer and why others fail over time. When a product is loaded within its elastic range, it can handle forces without damage. But if the force exceeds the elastic limit, plastic deformation begins, weakening the structure. Repeatedly bending a metal wire beyond its elastic limit causes it to weaken and eventually break. This is why engineers carefully select materials with the right elastic and plastic properties for specific uses. For example, materials with high elasticity are used in flexible devices or shock-absorbing parts, while those that can undergo plastic deformation are used in shaping and forming processes. In everyday life, elastic deformation is seen in things like rubber bands, trampoline springs, and even in the suspension systems of vehicles. Plastic deformation is involved in forging metals, shaping plastic objects, and even in the dents and bends we see in damaged cars. Recognizing how materials respond to forces helps us design safer, more durable products and understand why some things break after repeated stress. It's all about balancing how much a material can stretch temporarily versus permanently, ensuring that structures can withstand the forces they face without failing.